Okay, so today we're doing find the equation of a quadratic. So we want to learn the strategies and skills involved in converting a worded problem into an equation, specifically a quadratic, and then use this quadratic equation to predict or analyze information. Okay, so some of the success criteria. We need to be able to correctly convert worded problems into an equation, as I said, specifically quadratic. We need to be able to demonstrate problem-solving skills, and we need to correctly use equations to predict other points. So here's an example. I'm going to do the example and then use the example and work on a different sheet. So we have a ball. It's thrown upwards from ground level and reaches a height of h meters after t seconds. And after 1 second, it is 12.5 meters above the ground, and it hits the ground after 5 seconds. So what I'm going to do, my first strategy is to draw a diagram that kind of represents this. And I'm going to do it on a Cartesian plane, kind of like this. Okay. I'm going to have my independent variable being the time, so t in seconds. And I'm going to have the height of the ball being my dependent variable. Height of ball. So basically what I'm kind of saying is that, what it's saying is as the ball is thrown up, it reaches a certain point, and then it comes back down, okay? So whatever comes up comes down, okay? So we assume that at 0 seconds, the ball is at ground level. So the ball is thrown upwards from ground level. So there's ground was at 0, it hasn't moved. It reaches a height, of h meters, so that's h, our height here, after t seconds, and at 1 second, the height is 12.5. So this point here would be 12.5. Yeah, 12.5. And then it hits the ground after 5 seconds. Yeah, and we can say it bounces later on. Yeah, but at the moment we just really care that it hits the ground at 5 seconds. Okay, so we want to find an equation for the height in h meters of the ball after t seconds. So we have like a negative parabola. We have a point, and what we can do is we can basically sub in what we know. We know that any parabola is in the form of ax squared plus bx plus c is equal to 0. Okay. We obviously know the initial conditions. Yeah, which is obviously at 0, it equals 0. So if I plugged in x equals 0, that would be 0, 0, and c equals 0. Yeah, so so ball is on ground level at t equals 0, so therefore c equals 0. Okay, so really now all I'm going to do is I'm working with ax squared plus bx. Okay, so we know one condition. So when t equals 1, h equals 12.5. Sorry. So basically, I can rewrite this in terms of t's and h's, right? So it should be at squared plus bt, c was 0 equals h. Okay, I'm going to plug in t equals 1, so that we've got a, because 1 squared is 1, plus b equals 12.5. Okay, let's call that equation 1. And we also know when t equals 5, h should also equal 0. Yeah, and that's this part here. So I'm going to plug in t equals 5. So 5 squared is 25, so 25a plus 5b equals 0. Okay, I'll just tidy that up a bit. Okay, so what happens now is I've actually got two linear equations which I can solve simultaneously. So I have this a plus b equals 12.5, equation 1, and I have 25a plus 5b equals 0. That's equation 2. So using substitution methods from equation 1, I can get a equals 12.5 minus b. Call that equation 2. And we're going to sub equation 3 into 2. So every time I see a, I'm going to replace it with 12.5 minus b. So I've got 25a, so I'm going to replace it with 12.5 minus b plus 5b, and that will equal 0. Okay. Plug that into the calculator. I've got 25 times 12.5, so 312.5 minus 25b plus 5b equals 0. Negative 25 plus 5 is negative 20, but I bring it over here, which is 20b equals 312.5. So divide it by 20, I get b being 15.625. Okay. So let's do, we've got a b value. I'm going to sub my b value back into equation number 3 to figure out what my a value is. So a equals 12.5 minus 15.625. 12.5 minus answer, I get negative 3.125. So therefore, the quadratic equation is minus 3.125 t squared, because that's my a, and that equals 0. Okay, so the equation of this parabola is negative 3.125 t squared plus 15.625 t equals h. Okay. Part C is, what is the height after 3 seconds? So we want to find out f of 3. So if it's somewhere over here, we're just going to plug it into our equation. So negative 3.125, 3 squared plus 15.625 times 3. The height is 18.75 meters. 18.75 meters. And we want to find part C was, what time does the ball commence to fall to Earth? So we're really trying to find the local maximum. Okay, so if we think of this as our x-coordinates, our x-intercepts, our axis of symmetry happens halfway, which is obviously going to be at negative, at 2.5. So we're going to find out what f at 2.5 is by subbing that into our equation. So I'll just go back, 2.5, and we get 19.53125 meters. Okay, so f of 2.5 is 19.53125 53125 meters, and f of 3 was 18.75 meters. Okay, so that's example 1. Okay. Example 2. Okay. Basically, it's stating that we have 3 points. So I have 2, 3. Yep. I have 1. So 1 minus 4, and then I have -1 minus 12. So, and it says that if these places fall on the same line. So it means that I've got some kind of quadratic that might look like that. And so really what I want to do is find the equation of the parabola that passes through these points. So what I'm going to do, so remember that we have the general formula of ax squared plus bx plus c equals 0. So using 2, 3, so 2 squared becomes 4a, plus x is 2, that's 2b, plus c, and that's going to equal 3. Okay, so what I did is I substituted my known x values, and this became 3, because that's my y value. Okay, let's call that equation 1. So using the next point, so 1 squared is 1, so that just becomes a, plus b plus c equals -4. And let's do the third one. So -1 minus 12. So -1 squared becomes 1. But that becomes minus b because that's -1. So minus b plus c, and that's equal to -12. So now I have 3 equations with 3 unknowns. And so what I want to do is I want to try to solve this simultaneously. And I'm going to do it logically. I'm going to add equation 1 with equation 2. And then I'm going to add the same equation 1 with equation 3 to make 2 new equations. So 1 plus 2, that becomes 5a. 2 plus 1 becomes 3b, plus 2c. And 3 plus -4 becomes -1. That's going to be equation 4. So I'm going to begin equation 1. I'm going to add it with equation 3, sorry. So I added that together, and now this together. So 4a plus a becomes 5a. 2 minus 1, it just becomes 1. And that becomes 2c. 3 plus -12, -9. Yep. Okay. And that's going to be equation 5. Now I look at these 2 new equations that I've created, and basically what I'm going to do is I'm going to try to cancel out some by adding or substitution or elimination. I'm going to try to cancel it out. And what I'm going to do is I'm going to actually subtract both equations, because I've got 5a and 2c, so I can figure out what b is. So equation 4 minus equation 5. Okay, so 3 minus 1 is 2b, minus 1 minus becomes plus 9, so that becomes 8, so b has to equal 4. Okay, so b equals 4. Using these equations again, I can substitute b equals 4 into here. Okay, so I'll do that maybe in blue. So I don't know what a is. Yeah, but b is 4, so 2 lots of that is 8, plus c equals 3. Well, technically that's 4a plus c equals negative 5, because 3 take away 8, negative 5. So this is my, let's say, 1a. Yep. And we've got a plus 4 plus c equals negative 4. Well, that's just a plus c. Negative 4 minus 4 is negative 8. And that's my 2a from equation 2. Try it again. So we've got a minus 4 plus c equals negative 12. Move that to the side. Plus becomes negative 8. So as you can see, that's 3a. 2a and 3a are exactly the same. Okay. So what I want to do now is from equation 2a or 3a, we can get a equals negative 8 minus c. And I'm going to sub 2a into 1a. Yeah, so I'm going to sub this stuff into here. So every time I see a, I'm going to replace it with negative 8 minus c. That's plus c, and we've got negative 5. So negative 8, that becomes negative 32, minus 4c plus c equals negative 5. This is negative 3c. Bring over the 32, should be 27. So c equals negative 9. Okay. And now what I'm going to do is sub c equals negative 9 back into this 2a. Yeah. So we've got a equals negative 8 minus negative 9, which becomes 1. So therefore we've got a being 1, b being 4, and c equals negative 9. So if I was to plug it in here, I'll get the equation. I'm just going to double check all these values though. If I use these values for these equations, I should come up to here. So I'll do it here. So I've got 4 lots of 1 plus 2 lots of 4 plus negative 9. I should get 3, and I do. Yep. All right. Let's try here. We've got a being 1, b being 4, and c being negative 9. I should come up with negative 4. Excellent. And then the second part is I've got a being 1, b being 4, and c being negative 9. I should come to negative 12. Excellent. So I know that these values are correct for these simultaneous linear equations. So I'm going to plug these values into my general formula. So the quadratic is x squared plus 4x minus 9 equals 0. Okay. And now what we could do is we could complete the square to find the actual quadratic. So if I go x squared plus 4x equals 9, x squared plus 4x, half of 4 is 2 squared, that is 4. Whatever I do to one side, I do the other side. 9 plus 4 is 13. So this is x plus 2 squared, or squared, 13. And we can do x plus 2 plus or minus the square root of 13. Bring it over. We have x plus 2 plus square root 13. X plus 2 minus square root 13 equals y, or equals 0. Yep. And so that is my quadratic formula for this parabola. Okay. All right. Example 3. Okay. Okay. All right. Okay. So it says a gardener has 100 meters of fencing to form a rectangular paddock with a river on one side. That doesn't require fencing. So if I was, whenever I have a worded problem, I want to draw a diagram. So this is my river. And I'm going to do a rectangular paddock. Sorry. So this would equal this. And there's the river on one side. Okay. Now, the perimeter, I have 100 meters of fencing. So this this part here has to equal 100. Okay. So let's call that x. That will be also x. And really, if I had 100 meters of fencing and I wanted to figure out what the length of this, well, this is just going to be 100, because that's the whole thing, minus 2 lots of x. Yeah. So the equation of the perimeter will be p equals 100, because that's what's given. Yeah, and if we use that, we can use p equals x plus x, which is 2x, plus 100 minus 2x. That would equal 2x plus 100 minus 2x. The 2x's cancel, comes back to p equals 100. The area, though, is going to be x times 100 minus 2x. Now, if you were to expand that, you would get a quadratic. We get a equals 100x minus 2x squared, which is a concave down parabola. Okay, we want to sketch a graph to represent that. Okay, so yeah. Using this, we have our x-intercepts. Okay, we've got x is obviously equal to 0. We've also got 100 minus 2x equals 0. So that's 100, 2x, x equals 50. So we have this being 0 and up here being 50. And we have it, as I said, we had a concave down parabola, so it's something that looks a bit like this. This is obviously our length of our width, really. And this is our area of our rectangle. Okay. So we want to find what are the dimensions that this garden will provide the maximum area. So if this is the area, we want to find the maximum turning point. Okay, which is going to be halfway. So when x is worth 25, or when the width is 25, let's plug it in. We've got our area equals 25, 100 minus 2 lots of 25. Okay, so 25 times 50, 1250 meters squared. So that's when this point here is 120. So the maximum is obviously the width is being at 25. Sorry, the width is 25 meters, and the length using this formula, 100 minus 2 lots of 25 is going to be 50 meters. So 25 by 50 meters will provide us with the largest area of garden. Okay. And that's all our examples. Okay, so looking back at our success criteria, we need to be able to correctly convert worded problems, and I think that's the hardest. The more practice we do, the better we become at it. Sketch a graph to kind of represent what's happening. That's one of the problems going. So draw a graph, plug in what we know, state what we don't know, then try to work methodically using simultaneous equations or any strategies that we know to find the equation. Yep, and once we found the equation, we need to test it, and we should be able to prove things from that equation. Okay, thank you.